All right, let's actually work with scientific notation. We're often going to be having really big numbers multiplied or divided by other really big numbers, or sometimes like this, you get a really big number divided by something really, really small. So everything's either really big or really small. And what we're going to do first is make everything scientific notation, and then we can use some of our exponent laws and make things a little bit easier. So I would recommend that the first thing you do is just move this over, and traditionally you want to move things over to make the number, like for instance here, to make the number less than 10. So you're going to go 1, 2, 3, 4, 5. But that's only for our answers. I actually think it's easier if you move things over till you get the first thing like that, till you get a nice whole number like 52. So I got 52 times 10 to the, so I moved it over 1, 2, 3, 4. Now I took a big number and I made it smaller. So I'm going to compensate balance by making this bigger. So that's why it's a positive 4. And this says times. So here my decimal place is, I'll put it in red here. My decimal place is here. So I'll go 1, 2, 3, 4, 5, 6, 7. So I have 4 times 10 to the 7. Now is it a positive 7 or a negative 7? So I have a big number. I made it smaller. So I'm going to compensate and balance to make this bigger. Okay, so that ends up working out. Everything is balanced there. Now what we can do is a bit of our exponent laws. So when you're multiplying, these have the same base, so you can add the exponents. So 4 plus 7 is 11. And then we have the 52 times 4. So you need to kind of maybe do that off to the side. 52 times 4, if you don't know what that is. I imagine that's going to be 208. So 4 times 2 is 8. That is 20. So yeah, 208. So step number 1 was turn it to scientific notation. Step number 2 was use the exponent laws to kind of make things a little easier. In this case, the multiplication law. And then you can actually multiply the numbers, so 52 and 4, just like you've always done. Lastly, you need to move the decimal place over to make sure, like 208, that's a large number. We need to make that into a number less than 10. So the decimal place is at the end. We're going to go 1, 2. So we're going to make it 2.08. So I made this, did I make this number bigger or smaller? So I went from 208 to 2.08. So I made that number smaller. So I need to balance that by making this number bigger. Bigger by 2, because we moved over 2 spots. So this is going to be bigger by 2. So instead of 11, it's going to be 13. That's how you do that. So again, turn step number 1, make this scientific notation. I moved this over till I got 52. And then I moved this over till I get 4. Multiplied 52 and 4 to get 208. Did my exponent laws to get 10 to the 11. Moved the decimal place over twice. That made the number smaller, so I balanced it by making it bigger twice. So from 11 to 13. There's a lot going on there. So let's try it again. So step number 1 is to turn this into scientific notation. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So 24 times 10 to the 7. Now, I took this number, I made it smaller, I made it 24, so I'm going to make it bigger to balance it. So I did, it's a positive 7. And here, I moved decimal place 1, 2, 3, 4, 5. So then it's 8 point. So it's just 8. I'm not going to make it 80, I'll just leave it there, 8. So I moved it 5 times. Now I took 0.000008 or 0.0008. I made that bigger. So I need to balance it by making this smaller, which is going to be a minus sign. Okay. And this was, I can't remember where this was. 3, 6, 7. Okay. Now that you have that, you can, in this case, over here, we multiplied 52 times 4. Here we divide. 24 divided by 8. That's 3. And then our our exponent laws say whenever you're dividing and the bases are the same, you can subtract. So I've got 10, 7 subtract negative 5. Now when you're subtracting a negative, you're actually adding. So 7 plus 5. So this is 3 times 10 to the 12. And that's it. 3 is a number less than 10. Last time we got 208, so we had to change things around. Here, though, we only got 3. That is okay. I can say, let's do C, but apparently we don't have a C. We only have a D. So let's just go with that. Let's first make this a whole number. So 1, 2, 3, 4, 5, 6, 7. So 33 times 10 to the 7. So I made this number smaller. I went from 33 like a million or something, and I made it 33. So I definitely made that number smaller. So I'll balance it by making that side bigger, and it is a positive, so that's good. So I've got that as 1, and now I got this 1, 2, 3, 4, 5. That would be 1.1, so I'll do one more. 6, that gets me 11 times 10 to the 6. So here I went from a really small number and made it bigger. I made it 11. So I need to balance it by making this smaller. So I need to make this a negative 6. Now I can multiply, 33 times 11. I don't know what that is. So 33 times 11. 11 times 3 is 33. 11, or 1 times 3 is 3. 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 So 3, 6, 3. So I get 363. I had no idea what that was. And then the exponent laws say when you multiply and the base are the same, you can add. So 7 plus 6 is 1. Now, 363, too big of a number. I need to move the decimal place. So decimal place is at the end. So I'll move it over. 1, 2, 3.63. So did I make that number bigger or smaller? I went from 363 to 3 point. So I made that number smaller. Therefore, I need to make this number bigger. I made it smaller by 2 decimal places, so I'll make this bigger by 2 exponents. So from 1, I'll go to 3. So there you have it. That is really quite complicated, which is why we've got another 3 examples we'll do in the next video. So let me just zoom out here. And we'll do the next 3 right away.